All right, here we go. The 31st. All right, so what we're going to do today is we're going to begin our look at powers and roots. We're building that order of operations and talking about it. Now, I wrote it as powers, but what's another way of saying powers? Anybody just sing out? Exponents, right? Or indexes or indices, Index or indices. Okay? Indices is the plural of index, yeah? So, there's different ways of saying it, and you need to know all of them, yeah? And it's going to be in the lesson as well. Okay? Powers and roots. Now, roots we'll talk about in a minute. Right now, we're going to start with powers, and then we're going to go to roots. All right? And we're just be doing some basic work with these, so that you understand how they work and what the pieces are. Now, let me tell you very quickly that there is a place with exponents that messes with students. It makes you not understand what's going on. You have to focus on about when you're dealing with exponents and to make sure you're getting the answer right. Okay? So, pay attention. All right. So let's go to powers and roots. Index notation. Here we go. All right. So in this lesson, we're going to look at index notation.
What's a cat? There's two cats. Oh, it's not a cat. He's shooting cats. Oh my gosh! I want the cats. Can I have cats? It's animal. Oh,
He's scanning a cat and then making multiples of it.
Cat. Patient.
Yep.
So I looked at throwing the cats in the air.
Okay, there we go. Pretty impressive, yeah? Okay, here we go. So index notation, also referred to as exponents, indices, or powers, consists of a base and a smaller index to the top right. So let's just look at the drawing here. So in your notes, you should write index notation, yes, notes, using the note-taking system, right? That half-page note-taking system. I'm going to write it using letters just so that we can see what's happening. They used a number and example, but I'm going to write it using letters. You have A and then the little n off to the right-hand side in the upper corner, right? And the n is much smaller, isn't it? This is an example of index notation. Now, here they did it with number examples, but I'm going to do it with letters. This is something called general notation. In other words, A stands for any number, okay? And N stands for number. So I'm just using letters to stand for the numbers to hold as placeholders so that I can write the definitions for you, okay? Where A is something called the base, okay? And that's important. Know the words, okay? So what is the thing that so like in this example, what is the base?
2.
The 2, okay? And N is the exponent, power, or what? Index, okay? I always put index last because we never say that in the States, but doesn't matter. You'll see all three of them, okay? Now, so in this example they gave us, what is the index, power, or exponent? The 4. Everybody see the pieces? So you have a base and you have a what? Exponent. We happy with that? Okay, good. Now, I'm going to write something with the base. So hopefully you left a little room there. Okay, and because we need to clarify the base a little bit. The base, okay, is the thing. Notice I didn't write number. I wrote thing. So base doesn't always have to be a number. It's the thing, the exponent, and you can write it out if you have room. I'm just going to abbreviate because I don't want to run out of room. Exponent touches. Okay. Now, in reality, is the 4 touching the 2? No, but it's right up against it. You can see that they go together, right? And we'll see some other examples of what I mean by that. So, it's the thing. So does that mean it's always going to be a number? Nope. And it has to touch the base or touch the exponent. In other words, they have to be right next to each other side by side. Yeah? So could an exponent be separated from its base by another number? Could it be separated from its base by a letter? Could it be separated from its base by a multiplication symbol or any other operation? No. They have to be touching right next to each other or it's not the base. Okay? That's right.
That's kind of how that works.
You got to fix it. All right, there we go. Everybody okay with it? So what are the two pieces called? Base and exponent, right? The base is, and think about it, we need to say the base first because the base is where it all starts, isn't it? If you think about the base of something, that's the bottom and everything else is built on top of it, right? So base and what? Exponent. Excellent job, guys. Okay. The index or exponent or power, and this needs to be in your note, the index, exponent, or power, you can write one of them or all three of them. I don't care as long as you know they all mean the same thing. Tells us the number of times we multiply the base number by, and here I'm changing colors because I cannot emphasize this enough, by itself. Okay? So everything that I've underlined, I want you to write. The index, or you can say exponent or power, you can just write one word for that, I don't care, means the number of times we multiply the base number by itself.
Base number?
Or the base, or just put base. I don't like that. Just put base by itself. Okay? So the base by itself. Good job, Sally. Okay? Because is the base always a number? No. It just happens to be in this time. All right? So the base by itself. Okay? It can be a number, it can be a letter, it can be lots of other things too. As you move forward. Okay? Everybody got that down?
No, just not fully.
No, you don't need the example because we'll write the example next to it, right? So here's an example, okay? And I want to first tell you the biggest mistake that students make with this. If you have 2 to the 4th power, many students will say that's 2 times 4 or 8. Is that true? No, that is completely wrong. Never means that. 2 to the 4th power means 2 multiplied times itself, how many times? 4 times. It means you're doing repeated multiplication. The base tells you what you're multiplying. Okay? So the base tells you what you are multiplying. And yes, this goes in your notes. If I take the time to write it, I expect you to do the same.
Can we do the 2 equals 2 4 equals 8 and then cross it out?
Yep, I would because it tells you what you're doing, right? What it isn't. Knowing what it isn't is just as important as knowing what it is, don't you think, maybe? Okay? So the base is what you are multiplying. Yeah? Okay. Shh, guys, the exponent tells you how many times to multiply that base. Okay? So the base tells you what you're multiplying, and the exponent tells you how many times to multiply that base. Look familiar? Seen it before? Yeah? Okay, did you remember that it was called the base? Oftentimes what happens is, even if you have seen some of this material before, you haven't been exposed to the terminology too much, right? When you're first learning things, a lot of times teachers don't push the terminology. But now, as you move forward and we get into the algebra sections, etc., what's going to happen is you're going to be told some word, and you're going to have to know what to do based on that word, right? So it's important that you understand the terminology as well as how to multiply, add, subtract, divide, whatever, right? Okay, does it make sense? If I give you instructions but you don't understand the word, then you're not going to be able to do the math, right? Okay, all right. So the base tells you what you're multiplying. The exponent tells you how many times to multiply that base. And it's only the base if the exponent is touching it, right up against it, right? Does the base always have to be a number? No. Good job, guys. All right, everybody got that? Shall I move on? If I push the button, I can't get back to it. Okay. All right. So 2 times 2 times 2 times 2. Let's do that. 2 times 2. Now, here's an easy way to know how many times you've done it with numbers that you can multiply in your head. Use your fingers. 2 times another 2 is 4. Times another 2 is 8. Times another 2 is 16. Have I used all 4? Yeah, there you know how you've used them all, right? Okay? Make sure you're doing something, though, to make sure you're using them all. Now, everybody got your calculator handy? Of course you do. I forgot. It's all right. It's okay. No, it's all right. Just listen along. All right? Your calculator can do this for you, and you need to know how to do it. Okay? Now, if you already know, you're in good shape. What you're going to do with your calculator, now listen, I'm used to American calculators, and so sometimes the operations are different. So you got to do it and see if it works, and then we'll know how to do it. Now, if you already know how to do it, you can tell me these times. Okay? Yes. Yes, definitely write it down in your notes. Okay? So, for example, if you want to do 2 to the 4th power, okay? So to do it in your calculator, enter the base, whatever your base is, okay? And then you're going to find the exponent key. Now, you're going to see that there are different keys for exponents. You might have, for example, you might have an x squared button on your calculator. Do you see a button with an x to the 2? Okay. Well, that's fine as long as the exponent you're trying to use is a what? 2. Right?
8 times 2 is 64.
Okay. Because, no, it's 8 to the second is 64. Because 8 to the second is 8 times 8, which is 64.
Okay, I'm confused.
Okay. All right. Okay. So, yes.
These different buttons is one x to the power of 30.
There you go. And now, you may have on your calculator an x to the 3rd button. I don't know. Some calculators do, some don't. Do you on this one? Okay. That will work as long as the exponent you're using is a 3. Then, if not, you're going to have something, and it just depends on the calculator. Let me look at one of you. Those 2 are the most common exponents you're going to use. If you have any others, you're going to use the x to the box button. Okay? Yes.
I have to get the inhale.
Okay. So to use the x to that button, so you'll push. What you'll do is you'll put the base, then the button. Hold on a minute. Let me finish. And then the exponent that you want. Try that out and see if that works. Okay? So, you don't have to if you know it. Right. Yeah, if you're used to doing it. But is that the key? I want to point out something to you. This is also known as expanded. Have you ever heard that word before? Expand. It means to stretch something out. Okay? Right? So that's the expanded form. And you need to understand that. Okay? Okay, good. All right? So you need to understand if they ask you to expand it, that's what they mean to do. Okay? Yes? Okay?
We used to.
All right.
We used to, and then it stole.
Okay. Everybody got that written down? All of this written down? Everybody's happy with it? So I can go to the next screen? Is that a yes? All right. So, let's look at some more examples of indices. Now remember, I'm going to do a couple of examples with you, and then you're going to be doing some things on your own. And then I'm going to call on you for the answer. So you better be paying attention, right? Okay. So, if you look at this 3 to the 5th power. So, just call out, you don't need to raise your hand. What is the base of this exponent?
3.
Just sing out. 3. 3 is the base. Good. What is the exponent? 5. That means you're going to take 3 times what? 3 times 3 times 3. In other words, 3 times itself. How many times? 5 times. You guys, that's too funny. All right? Okay? That's fine, because if you have one of those moments, that helps you learn, right? Helps you remember it. No, because this is 3 times 3 times 3 times 3, right? It's not going to give you the same thing if you do 5 times 5 times 5. Okay, so the base is 3, the index is 5, so we multiply 3 by itself 5 times. And you see what they did? 3 times 3 times 3 times 3 times 3 is what number? Look up here. 243. Yeah? 243. There you go. So 243. That's a big number, isn't it? Yeah. So what you're going to see is, guys, when you're doing exponents, numbers get very big very fast. Okay? All right. And there you go. There's the expanded form again. 3 times 3 times 3 times 3, right? That's the expanded form. It's good? All right. Let's look at another one. Now. So here. The base is what?
2.
The index is what? 6. 2 to the 6 means 2 times what? Yep. There you go. 2 times itself how many times? 6 times. Right? Okay? So do it in your calculator. 2 to the 6th power. And what are you going to get? Yes.
Not that, but first squared, just do 6, and then times 6.
Right, if it's squared, that just means it times itself twice. Mm-hmm. Okay. Now, no. Just don't look at the bottom part. We're looking at the top part right now. So don't look at this. Don't look at this part right now. Look at this part up here. Don't worry about the bottom part right now. Now, so what if you reverse the numbers around? Are you going to get the same answer?
Yeah.
So 6 to the 2nd power. What's that going to give you? 6 times 6, which is 36. 6 times 6, right? Be careful, guys. Did I tell you that exponents can trick you easily if you don't pay close attention to what you're doing, right? So be careful. Now, on that one, you didn't have to use the box key. You could use that x squared key, right? So all you had to do was hit 6, then that key, and it gave you the answer. Because that one is a really common one, the squared one. Okay? Okay, let's see. Now let's do some indices. All right?
That looks evil.
Oh, it's fun colors. That's not bad. What would that be? 1, 2, 3, 4, 5, 6 threes. So 3 to the 6th power. Right? If you have the expanded form, you can do that. Okay? Now this one's actually from your homework. I want you to do it. Go. Work on your own. Okay. Work on your own means... Yes, ma'am.
Is that stuff that we did yesterday with the rest of it?
I beg your pardon?
Is this the stuff that we did yesterday with the rest of it?
It's part of it, yes. Okay? So we're going to do some more with indexes. Remember again the notation, base and index. Excellent. Make sure you know which one's which. Okay? There are lots of ways to describe numbers in index notation. Some types of indices happen so often that they have special names. Okay? For example, if you look at this one, that's 2 to the second power. It's also known as 2 squared. Anything raised to the second power is often called squared. And that comes from geometry, right? Because if you're doing area, specifically area in geography, you take one side times the other side, right? So and if they're in meters, meter times meter becomes meters squared, right? So anything times itself, guys, anything times itself is known as squared. And that simply means, so if I say squared, you think exponent of 2. Okay, yeah, okay. All right. Another one that you must know is cubed. That just means anything raised to the third power. Anything else, power 6, power 4, they don't have special names. Okay? Yes, ma'am. Pardon? Okay, we'll get there. Hold on. Don't be borrowing trouble. Hold on. All right? So in this section, you're going to be given the expanded notation. You're going to have to write the exponential notation. So it's 5 times itself 4 times, which makes what? 5 to the power of 4. There you go. Okay.